Hey everybody, today we're doing another math problem, and today we're doing this sine to the fifth x dx, right? We're taking the integral of that, and it's going to be a little more complicated than the last problem because this is a higher power function. Okay. So we do the same thing. We analyze the problem. We know that we don't have a limit of integration. So basically, we just evaluating the integral. In other words, it's an indefinite integral. Okay. So okay. So first of all, we need to work this out to make it before we use the u-substitution, we have to work this out to make it easier for us to use some trigonometric identities, right? So, so what we can do is make this break it down into two different functions, I would say. Or, yes, you can say break it into two different functions, or make it this an even power so we can use a trigonometric function. Okay? So basically we can do this. We can write this as the integral of this, right? So the integral of this sine x to the fifth power, we can write it as sine to the fourth power x, right? And then we can write this. We can just put another sign of x and then dx, right? Because technically this is the same thing. If I multiply this again, I will get the same thing. Okay, I will get sine to the fifth power here. Okay. Now we can use a trigonometric identity. We can use that the fact that sine square x plus cosine square x is equal to 1, right? So when you solve for sine, you take away cosine square x and cosine square x, and you get sine square x is equal to 1 minus cosine square x, right? So using this identity, we can substitute it in here. Okay? So now, let me do that right now. Okay? So we can rewrite this integral as the integral of 1 minus cosine square x sine x dx. Okay? But here, because I have it to the fourth power, I can rewrite this cosine, this identity multiply to the second power, right? Now we can use, we can distribute this, okay? Or we can multiply this piece inside the parentheses, okay? Multiply it by itself, okay? Or we can distribute whatever term you want to use, okay? We can actually multiply this, and then we combine like terms, and then we'll get another type of expression, right? So, so we can do that, okay? So let's do it. So let's do 1 minus cosine square x times 1 minus cosine square x times sine x dx, right? When I distribute this, I get the integral of 1, right? This times this is 1. This times this is negative cosine square x. This negative cosine square x times this is negative this is negative cosine square x, okay, and then negative cosine square x is equal, negative cosine square x times negative cosine square x is equal to plus cosine square x, right? Actually cosine to the fourth, okay? And then sine x dx. Okay, now we have this, we can combine this like this and this like terms, and we get 1 minus 2 cosine x, okay, minus 2 cosine square x plus cosine to the fourth x sine x dx. Okay, now we can use the u-substitution here, okay? We can use the u-substitution here, but somewhere here, but right now what we can do before that, we can say that u is equal to cosine x, right? Du is equal to negative sine x dx. Okay, so du, sorry, here sine x dx, right? Then sine x dx is equal to negative du, right? Just divided by a negative 1 on both sides. Okay, now now I can actually do this. Now I can substitute this, whatever they have a cosine, I will substitute it with a u, right? Okay, so negative, and I can say that the integral of 1 minus 2u squared plus u to the fourth, and then negative du, right? Negative du, okay? But then this negative du can just come out at the front, okay? I'm sorry, the negative 1, just negative 1 can come out at the front, and I get this integral here, right? Just the negative sign gets pulled out in front of the negative, the negative sign gets pulled in front of the integral sign, okay? And when I integrate that, I get minus, I get u plus minus 2u squared cubed, right? Minus 2u cubed. And then plus, you can say plus 1/5 u to the 5th power plus c, okay? Now, whatever I see at u, I have to substitute with a cosine, but before that, I will distribute this sign right here. The negative sign, I will distribute the negative sign inside the bracket, and I get negative u plus 2/3 u cubed minus 1/5 u to the 5th plus c. Okay? Now the final answer is going to be negative, the final answer is going to be negative cosine x, cosine square x negative cosine square x, right? Plus 2/3 cosine cubed, right? X minus 1/5 cosine to the fixed power x plus c. Okay, so this is the final answer. Actually, no, this doesn't get square, I'm sorry. Just like that. Okay. Okay, so sorry about that. So this is the 5th power, right? So that is the answer for this integral. So this is the answer for this integral. And again, it was a little more challenging than the last problem. But problems like this require a little more work. But if you use the trigonometric identities that you learn from pre-calculus, they are really helpful to solve this type of problems. So that's it for this tutorial. I hope this helped anyone who has taken some type of calculus. Thank you for watching.